Euler's totient function. What is Euler's totient function? If n is any positive integer, a is any positive I, then a raised to phi of n is congruent to 1 modulo n. What is phi of n? Phi of n is Euler's function. First I will explain what is Euler's function, then I will take one case study, then I will wind up the process. To find phi n. For example, you take, can you remember in the last session I explained division or unique factorization theorem. Unique factorization theorem is the basic fundamental to find phi of n. For example, n equal to 24. We can write 24 as 2 power 3 into 3 power 1, is it? 2 to the power of 3, 8, 8 into 3, 24. What is the basis? Bases are 2 and 3, with P1 equal to 2, P2 equal to 3. Therefore, phi of 24 is n times 1 minus P1 into 1 minus P2. You have P1, P2, P3, continue till that. That is equal to 24 times 1 minus P1, that is 1 by 2 into 1 minus 1 by 3, that is 24 into 1 by 2 into 2 by 3. So it cancels to get 4, answer is going to be 8. This is phi of 24. I will show you one more example, case number 1. Case number 2, I want to find for n equal to 360. So we can write 360, we can write 24, we can write 2 raised to 3, 3 raised to 2 into 5. Cross check. 2 raised to 3, 8, 9 into 5. Let's see. 8 into 9 into 5, 360. Exactly correct. So what is P1? Your P1 equal to 2, P2 equal to 3 and P3 equal to 5. Therefore, phi of 360 is n 360 times 1 minus 1 by 2 into 1 minus 1 by 3 into 1 minus 1 by 5. So that is equal to 360 times 1 by 2, 2 by 3, 4 divided by 5. 5 3s are 15 into 2, 30. 360 by 30, 12 into 8, 96. So phi of 360 is 96, phi of 24 is 8, like that. Once you can generate, see what is the disadvantage of Fermat's-Little theorem? Fermat-Little's theorem you cannot apply when the divisor, that is modulo class, is not a prime. What is an advantage of Euler's totient function? For any n I can find. Not necessarily p, it can be anything. I will show you one problem. Find last digit of 7 to the power of 1983, where India won the World Cup. Okay? Last digit of 7 to the power of 1983. So what is the model? The model is to find R such that 7 to the power of 1983 is congruent to R mod. When I say last digit, I should consider the divisor as 10. Last 2 digit 100, last 3 digit 1000, like that. I am taking only one case, a simple case of last digit. Now what is your n? 10, which is not a prime number. You cannot apply Fermat's Relativity theorem. Only option is Euler's Tottian function. Now what is Euler's Tottian function? By Euler's Tottian function, we have a raised to phi of n is congruent to 1 modulo n. So that means I should tell what is your n. To that n I should find phi of n. My n equal to 10. To find the phi of 10, first you write 10. 10 equal to 2 raised to 1 into 5 raised to 1. This is unique factorization theorem. Now I can write phi of 10 equal to 10 times 1 minus 1 by 2 into 1 minus 1 by 5. That is 10 times 1 by 2 into 4 by 5. The answer is simply 4. I'll do here this side, okay? By Euler's Tottian function, I can write 7 raised to 4 is always congruent to 1 modulo 10. This is the beauty. But I don't want power 4, I want power 1983. We can write 1983 as 4 times is 495 plus 3. So we want power, we had power 4 multiplied by 495. Raise 7 to the power of 4 raised to 495 is congruent to 1 raised to 495 modulo 10. That is 7 raised to 1980 is congruent to 1 modulo 10. But I want additionally 3 with base 7. Multiply 7 to the power of 3 both sides. Then we have 7 to the power of 1980 into 7 to the power of 3 is congruent to 7 to the power of 3 modulo 10. That is 7 to the power of 1983 is congruent to 343 modulo 10. 10 bigger than or 343 bigger than. So what do you do? 343 divided by 10. It is 34.3. Good by this. Multiply. I'm going to get here. 7 to the power of 1983 is congruent to 3 modulo 10. The remainder or equal to. This is how we can enjoy the number theory, and most interesting component of the number theory is cryptography. I will do one.